Hi friends, I Robinson. Welcome to our YouTube channel Star Science. If you've not been subscribed to our channel, do subscribe and encourage me. Let's get into the topic. This video is about nephron anatomy and its function. We will see clearly what are the structures of nephron and what are the certain functions of nephron. Basically, we have to know all the parts of the nephron one by one. Let's see through the diagram. I want to draw nephron and I'll explain each part of the nephron. First of all, we have to be well known about the nephron. Nephron is almost 2.5 millions in both the kidneys. You have to remember the structure which I am drawing right now. It is the Bowman's capsule, following it proximal convoluted tubules, followed by descending loop of Henle and turn out to ascending loop of Henle, and then distal convoluted tubules. After that, it joins to the collecting ducts. From there on to renal papillae, and from them it will be major calces, and from there renal pelvis. From there it connected to ureter and to the bladder. And now we are going to see all the parts of the nephron in detail. What will be the work of each part of the nephron detailedly we're going to see right now. After this diagram, I just concentrate on the Bowman's capsule. Now we are going for the Bowman's capsule, where you have to remember this particular part. It is called as Bowman's capsule, and this Bowman's capsule, the outer region, it is made up of certain cells, and the cell is called the parietal epithelial cells. The parietal epithelial cells, where I am drawing right now, this part, it is called as parietal epithelial cells. And when you have to remember, in between of this parietal and inner part of the cell, we'll go into detail in lecture later. So that particular space where the filtration, which is filtered by the glomerular filtration, will be collected in that particular space. So now we have to remember this Bowman's capsule, which is outer, it is parietal epithelial cells. So take a note that it's very important to know that some of them will get confused with parietal epithelial and visceral epithelial. So the parietal epithelial, where I have been drawn here, you can get the identification clearly without any confusion. And after this, we are seeing where I am giving the arrow mark, that particular place where it is called as Bowman's space. I mean, the two layer, the one is parietal epithelial, and I have then said right now the next layer we will see. In between of these two layers, there is a gap or a space which is called as Bowman's space. And from there on, we'll move to the next part, where I am going with red, because this is the afferent arterioles, and it enters into the glomerular filtration, and then it exits as a efferent arteriole. The thing we have to remember is where the blood will bring oxygenated blood, but it has a waste in it in a afferent arteriole. When it enters into the glomerular filtration, after filtering all the waste, again it takes back to the efferent arterioles. So some of them will get confused. These efferent arterioles are veins. At this point of view, it is not as an vein. It is still an artery. And where I am drawing right now, these particular regions which will be podocyte cells and which is attached to the Bowman's capsule. So as we seen the parietal epithelial cells, so in these particular regions you have to remember the inner lining where it is called as podocytes, and it is also called as visceral epithelial cells. So now you can get the view clearly where the Bowman's space is. The parietal epithelial and visceral epithelial in between the space is called Bowman's space. And where I am drawing right now, this particular region where it is called the glomerular apparatus. So this particular region, it has almost certain cells we are going to see one by one. Now in this just a glomerular apparatus, we can see the cells which is useful for retention of NaCl, at the same time for maintaining of the blood pressure. So all the particular things which will be done by these cells as we are going to see right now. So the first cell is granular cells, and followed by the next cell, it is called, from this place I am showing right now, and it is called as macula densa cell. So we have to remember these cells. Now for the structure or anatomy purpose it's okay, but when it comes for pathological conditions, all the cells are very responsible in pathophysiology. And now we are going to see about the third cell, which we are going to see that is very important cell, and extra glomerular mesangial cells. So these three cells are very important in this glomerular filtration. So these cells which will make glomerular functions. So I hope you can understand where is the glomerular filtration is. Now I am drawing this particular cells which is in afferent arterioles and efferent. It is called, or it is made up of endothelial cells. So the afferent arterioles are made up of endothelial cells. So it's very important to remember, because after this anatomy, when we go for any pathological conditions, it's very important. Now again we'll go into next detail. Right now I'm showing you about the afferent arterioles, and other side it is called as efferent arterioles. So the blood which comes from the renal artery will enter into the afferent arterioles. After filtration in glomerular filtration, it exits out through efferent arterioles. So the important information is that the waste will be filtered but not the gases. So the O2 blood will be continuous flowed from the afferent to the efferent arterioles and other parts of the nephron, because PCT are very much needed of the O2 blood. The PCT cells which are present in PCT are very much needed of O2 blood. It's very important to remember. Right now I am showing you the blood which enters from afferent arterioles are going to glomerular filtration. Right now we are seeing it, and after filtration it exits out through afferent arterioles, so it comes out of from glomerular filtration. So it's also very important to remember. And after this Bowman's capsule and glomerular filtration, it's very important to remember about the PCT. So after this, as we're going for the PCT, so proximal convoluted tubules, as we're going to see from the part where I'm showing right now. From here is the place where Bowman's space, where the filtered, which the afferent arterioles which entered into the glomerular filtration after filtered, and the filtered content will be sent into the Bowman space. From there it will be passed through proximal convoluted tubules. So it's very important to know that what are filtered from the glomerular filtration from the blood. And right now I'm writing about the PCT, that is proximal convoluted tubules, and we have to know the filtered content. We'll see in later in our lecture, but right now we are going for the parts proximal convoluted tubule followed by continuity of descending loop of Henle. Right now I'm showing you, so this part till here is almost a PCT, and from here it is called as descending loop of Henle. So whenever we see descending loop of Henle, it will be in a thinner way, thin pipe. So you have to remember, when you go for a diagram in your exams or anywhere, you have to draw the PCT in a wider, and when it comes for loop of Henle, it should be thinner. And this is descending loop of Henle, and what are the filtered content which is passed from PCT or proximal convoluted tubule will flow to the descending loop of Henle and turn over, and it passes from here, it is ascending loop of Henle. So the waste which is filtered from the blood in glomerular filtration is reached now till the ascending loop of Henle. So from this particular point you have to remember, again it gets wider. This particular phase, it is called as DCT, distal convoluted tubules. So you have to remember, it's very important in nephron anatomy because it is the main structures which will make all the functions in nephron to make urine. So distal convoluted tubules, after that it go and joins to a collecting ducts. So everyone will be confused when it comes for the collecting ducts. We can see so many branches where right now I'm showing you. So you don't get confused because we have 2.5 millions of nephrons. So all the nephrons which is end part of nephron, that is DCT, will be connecting to the collecting ducts. So that is the thing you have to remember. So particular point right now I'm showing you this place where in apex of pyramids, renal pyramids, where it is called as renal papillae. So it's very important to remember all this structure and points, and when you have remember all these things in your mind, it's very important to know what are the real functions of it in later lecture. And from here we'll see what are the content which is filtered in glomerular filtration. After filtration, when it enters into the Bowman space, and from Bowman space, what are the exit content which is filtered from the blood to the Bowman space. So right now I am going with filtrations. What are the filtered have reached Bowman's space. So I am giving in this box to get remembered, so do take a note. So firstly you have to remember the filtration which is filtered by the glomerular filtration. So all the filtration content are, now we are saying, water, sodium and potassium and bicarb, amino acid, glucose, creatine and urea. So you have to remember these are the filtered contents which is passed from glomerular filtration to Bowman's space. So after this filtration, when it passes from Bowman space to PCT or proximal convoluted tubule, there we will be having an reabsorption, means it takes back. So what are the reabsorbed contents we are going to see right now. So the reabsorption, where I am going with R, just it indicates reabsorption. So the reabsorptions are from the filtered content which passes through PCT, that is potassium, bicarb and water, sodium and glucose and amino acids. So these are reabsorbed in PCT. So you have to remember, it's very important to know that filtration is nothing but from the blood which is filtered, or the waste which is filtered through glomerular filtration after it passes from the Bowman space to PCT. So in PCT there will be two actions, one is reabsorption and next one is secretion. So reabsorption is, we have given the content what is reabsorbed. Now we are going for the secretions from the PCT, means after taking and certain contents, it releases certain, or it secretes certain things, that is nothing but uric acid and organic acids, which will be secreted from proximal convoluted tubules. So you have to remember the following is regarding descending loop of Henle, where it is only reabsorption occurs, where only H2O, that is nothing but water, is reabsorbed. So when it comes for ascending loop of Henle, there it will be reabsorption of sodium. And now we are going for the distal convoluted tubules, where it secretes and reabsorbs. So first we'll see about the reabsorption. So it is about some portion of sodium and water will be reabsorption occurs in DCT, and secretion, that is nothing but potassium and hydrogen ion. So these are the content you have to remember. So when it comes for the collecting ducts, where there will be again certain things will be reabsorbed, that is urea and sodium chloride and water. So in collecting that, after reabsorption of this thing, this contents, again when it comes for the final stage, where that is excretion. So you have to remember in excretion what are the contents again. So you don't get confused by making every parts reabsorption. You just think that certain amounts will be reabsorbed and certain amounts of it will be still left in it. When it passes by in that nephron, you will be finding all the places it will be reabsorption and secretions. So now you are coming in excretion. The contents are urea, sodium chloride, water and potassium, creatine and urea. And you have to remember these are the content which is released in renal papillae. So this content, it is called as urine. So this is the clear structure of nephron and the functions of nephron. It's very important to know the clear structure and functions of nephron. I hope these are very detailed nephron anatomy and physiology of nephron. So I hope you got an information which is needed for you. These are the content of urine formed from the nephron, and these are the waste which is filtered by glomerular filtration from the blood. Now we're going to see there are two types of nephrons. I'm going with both the sides in above, where you have to remember certain types of nephron. So firstly, just a medullary nephron. So the just a medullary nephron, I'm going with the structure. Carefully watch this nephron as I'm drawing right now on the board. The justamedullary nephron, it has Bowman's capsule, glomerular filtration, afferent efferent, and from Bowman's capsule it has PCT, loop of Henle, both descending and ascending, and DCT and collecting ducts. You can think that then what is the difference? And other side, I'm going with cortical nephron. So these are the two types of nephron. One is just a medullary nephron, next is cortical nephron. And the difference between the just a medullary nephron and cortical nephron, through diagram, I just want to draw here. Let's see. So Bowman's capsule and PCT. When you see the loop of Henle, it's very long in just a medullary nephron. And this is the only thing you have to remember, difference between just a medullary nephron and cortical nephron. So then followed by DCT and others to the collecting ducts. So in Bowman's capsule, again glomerular filtration, again I'm going with red, that is afferent and efferent. So everything are similar, but where I'm writing right now, that is loop of Henle, it's very long. So the just a medullary nephron has the loop of Henle too long than the cortical nephron. So here the simple way is to remember that, and the important point is that the long loop of Henle will enter into the renal pyramids, that is medullary region, and this is the only changes you have to remember. So I'm going for the blood supply here for for the just a medullary nephron, and afferent and efferent I have given. So afferent is nothing but from the renal artery, and again I'm going with the cortical nephron, where it has Bowman's capsule, PCT, and short loop of Henle, and it has DCT and Culting ducts. So the thing you have to remember is it's very short because the loop of Henle are short, but everything are similar. Because of this loop of Henle is short, this is cortical nephron. So cortical nephron, it is not fully entered into the medullary region. So that is the only difference we can find between just a medullary nephron and cortical nephron. So when I had given the afferent arteriole, right now you can see, and efferent arteriole, where I am writing right now, it is about the short loop of Henle in cortical nephron. So take a note that the important is the difference between a just a medullary and cortical nephron are long loop of Henle and short loop of Henle. Right now I'm going with the blood supply in cortical nephron. So after afferent, when it reaches to the efferent, it start giving the blood supply to all the parts. Because it's very short, there is no needed in between, but it directly gives the blood supply to the PCT and all the parts of the nephron. In just a medullary nephron, the blood supply after efferent arteriole, it just goes into nearby PCT and in between of the loop of Henle, and it gives the blood supply in to loop of Henle, and from there it divides a branch. So these particular branches, it is called as vasorecta. So after that, when it gives certain small capillaries to the DCT and PCT, so where it is called as peritubular capillaries. So we can't find this in cortical nephron vasorecta, but we can find in just a medullary nephron. So after this vasorecta, it gives the branches from there, as I given you clear indication in blue, where the connecting to the aquate vein. So from there it goes to, most probably I'll give you clear indication in down part, the blood supplies, how it enters into the arterioles, I mean afferent arterioles. After efferent arterioles, how it becomes, I mean deoxygenated blood, and how it enters into the infravena cava. So I want to give you clear structure that just a medullary nephron and cortical nephron, they are the two difference. That is, loop of Henle is longer there in just a medullary nephron, and cortical nephron, it has short loop of Henle and it doesn't have vasorecta, but the just a medullary nephron has the vasorecta. So this is the two different things you have to remember, and it will be useful for you in your studies. Finally, let's go with the kidney structure, not in detail, but I want to show this afferent and efferent, the blood supply from renal artery, from there to afferent arteriole, how it reaches, and from efferent arteriole to inferior vena cava, how the blood supply will again from kidney reaches to inferior vena cava. So we're going to see in this. Right now I am going for the cross sections of the kidney. So where I am showing right now the nephron structure in a kidney. Just I'm drawing only one. You just think in this structure, it is situated in kidney. So this is the nephron. So this is most probably just a medullary nephron. If it is away from this pyramid, renal pyramids, so right now I am showing you this is cortical nephron. So that is the difference you have to remember. So when there is long loop of Henle, it enters into the renal pyramids, but whereas cortical nephron, because of its short loop of Henle, it not fully entering into the renal pyramids. So these are the two changes. I hope this is very clear to you. And right now I am going with the blood supply from the aorta and the main blood supply which comes from the renal artery, and we are going for the branches. I'll just draw these branches and just I'll explain the parts of this particular arteries. First we have to remember, and before entering into the glomerular filtration, I mean afferent arteriole, so how it resembles. So we'll see all those things right now. So the particular part which is passes, and I'm showing you right now, and the blood supply to the kidney, and from kidney CO2 blood, how it gets out of the kidney. So now I'm showing you, just you remember the afferent arterioles, how where it starts, and right now I'm showing you vasa recta. I mean from there it's go for a next level. I mean CO2 conversions will take place in this particular regions. So from here it means that from afferent arteriole, when it goes for vasa recta, and it will enter into the veins. The first thing you have to remember, when it enters into the vein, so it is not from efferent arteriole. So from efferent arteriole, after giving to all the parts of the nephron, it will go down to the loop of Henle, and it gives branches. From there the vein starts. So aquate vein, from aquate vein, so it gives down the branch, it is called as interlobar vein. So from right now I'm showing you, it is called as interlobar vein. So aquate vein to it flows to interlobar vein. From interlobar vein to right now I'm showing you this particular region, it is called as segmental vein. So segmental vein receives CO2 blood from interlobar vein, and it passes from the renal hilum to the renal vein, and from renal vein it passes to inferior vena cava. So this is how oxygen will go into the kidney, and CO2 blood will come to the out of the kidney and joins to the inferior vena cava. And now you'll see the blood supply to the kidney, that is from aorta, renal artery. The renal artery will enters into the renal hilum and into the kidney. So when it entered into the kidney, it gives a branch. Right now I'm showing you, this is renal artery outside the kidney or pre-renal. So this is renal artery, and once it entered into the kidney, it again different artery. So as soon as it entered into the kidney, now I'm showing you that branch, it is called as segmental artery. So this renal artery carries blood from aorta into the kidney through renal artery, and as soon as it entered into the kidney, it gives a branch, that is segmental artery. From there it gives the branches in between of the renal column, where it is called as interlobular artery. So after that it come near to the cortex region. So where the cortex region, you can see the nephron presentation or structure. So where it is called as aquate artery. So this artery aqueous artery, right now I'm showing you, it enters into the glomerular filtration. So that is continuation of this aqueous artery. That artery is called as afferent arterioles. So these are the real structure of nephron and how the nephron is situated in the kidney. I hope you are well known facts about nephron anatomy and physiology. I hope I have been very clear to you. If you have any doubts, you can just give in comment section and I'll rectify your doubts. And if you want any more videos regarding any other subjects or any other topics, just let me know so that I can do that particular topics. So friends, thank you for watching this nephron anatomy and physiology. I hope it is very useful to you. This video is from Star Science YouTube channel. If you want to subscribe, do subscribe and encourage me. I will do many more videos. Thank you friends. Do subscribe and share to your friends. Thank you. Bye bye. It's Robinson.